Number 1 asks you to find the roots, and remember the roots are where your graph will hit the x-axis. Roots, solutions, those are all asking for zeros. Those are all asking for where the graph hits the x-axis. So we're hitting at -3, at 2, and at 5. So then -3, 2, and 5, that's going to be choice 3. All right, let's look at number 2. It says, what are the zeros? Just like number 1, that's where we hit the x-axis. So if we look at that, that is -3. We also hit the x-axis at -1. And we also hit the x-axis at +2. Okay, what are the factors? So we just take those zeros and we change their signs. So we have x plus 3 is a factor, we have x plus 1 is a factor, and we have x minus 2 is a factor. Okay, now to find the leading coefficient, I would start by writing an equation. So f of x equals c times those factors. Now be sure to check when you're writing an equation that you don't have any wiffle ball action going on here. Okay, any points where the graph is tangent to the x-axis. So for example here, the graph goes entirely through the x-axis, goes from one side through to the other. The same thing here and the same thing here. Whereas if you look at the graph in example number 1, we have a tangent right here. It ricochets, it hits the x-axis, and then bounces right back off of that. Okay, because if we had that, remember then one of your factors would have to be squared. So this, if this was a factor, this would be x minus 2. We would have to square that. Okay, so getting back to the question that we have, remember when we have this equation, to find c, we need to find a point that's on this graph and plug it into this equation for x and y. I like to use the y-intercept, which is 0, 6. So I'm going to use the point 0, 6. I'm just going to put it over here because I can't fit it. And that's what I'm plugging in there. So I'm going to have 6 equals c. And then we're plugging in 0 everywhere we see an x. So if I plug in 0 into the first set of parentheses, I'm going to get 3. Second set, I'm going to get 1. And in the last set, I'm going to get -2. So that's 6 equals -6c. So c is -1. All right. And it just said to find the leading coefficient, so we don't need to write the equation. What is the degree of f of x? So remember when we find degree, we see that we have 1, 2, 3 direction changes. So 3 direction changes means it's an odd degree, and an odd degree function, and it is a third degree. Okay, now E says state the coordinates of the maximums and the minimums. Well, I see here I have a minimum, and that appears to be at -2, -6. So I'm going to write that off to the side over here because I can't fit it. So I have a minimum at -2, -6, and then I have a maximum over here, and that's at 1, 8. Okay, so I have a max at 1, 8, and there is my answer for part E. Number 3, zeros. So I'm going to have -3, -1, and 2. Now I probably shouldn't have written it this way, but with multiplicity. So I'm going to look at this graph, and you can see I have multiplicity 2 here because I have a bounce. And remember here where it goes from a concave down to a concave up. Right here, that point, that 0, is going to have multiplicity 3. Okay, so this -3, that's a normal one. So that has I'm going to abbreviate the word multiplicity. Multiplicity 1. Okay. This guy here, oops, has multiplicity 3. And then this one is a tangent, so that one has multiplicity 2. Okay, what are the factors of f of x? So again, we just changed the sign. So we've got x plus 3, we have x plus 1, and we have x minus 2. Write an equation. So if we write the equation, remember we're going to have a value for c, which we'll deal with in a minute. So x plus 3. Now remember, because we have a change in concavity at that x equals -1 spot, that means we're going to have a degree 3, or multiplicity 3, I should say, I'm sorry. And then this guy would be x minus 2, and that's a tangent, so that value is going to be squared. Okay, I like to use the y-intercept, so I'm going to use 0, 10 as the point that I'm going to plug in. And so I'm going to get 10 equals c times 3 times 1 cubed times -2 squared. Okay, so that's going to be 10 equals, now let's figure this out. So we've got 3 times 1 cubed is 1, -2 squared is +4. So altogether that's going to be 12c. And then we're going to divide out that 12. Okay, I know I'm squeezing it, sorry about that. So c would be equal to 5/6. Now, if you read the question, though, that's not what it's asking for. It's asking for the actual equation. I'm kind of running out of room here, so I'm sorry, but I'm going to put it up here. So the final equation would be f of x equals my c value, which is 5/6, and then x plus 3 times x plus 1, that quantity cubed, and then times x minus 2, that quantity squared. And there's your answer for part C. Okay, end behavior. Now remember, when we do end behavior, it's always as x goes to -infinity, and then also as x goes to +infinity. And then what we want to know is, where does our y go to? So where does our y go to? All right, so remember, this really means look at the far left of the graph. And if you look at the far left of the graph, it's going up. So that means f of x will go towards +infinity. Now, remember, this means look at the far right side of the graph. And if you look at the far right side of the graph, that's also going up. So then your answer here would also be +infinity. Okay, so for number 4, they want to know which one could possibly be the equation for that picture. All right, so if you look, I notice I have 1, 2, 3, so that's at -3, which means its factor would be x plus 3, which means it's got to be choice 4, or it's got to be choice 2. Then this 0 right here is a +2, so that means its factor is -2. So again, still choice 4 or choice 2. So how about I just do this? We can cross off choice 1 and we can cross off choice 3. Now look at the difference between them. Their leading coefficients are different. So in 2 it's positive, and in 4 it's negative. And if you look here, this is pointing down, that's a frown. It's an even function, even degree function, so the answer is choice 4. Okay, so number 5 says write the equation for the polynomial of the graph and describe the end behavior. Okay, well, let's see. We know our zeros, so how about we look at those? So we have 1, 2, 3. So we've got x equals -4, x equals -1. So let me just stop a minute and write those down. So I'm going to have f of x equals c times x plus 4, because remember I have to change the sign, and then x minus 1, but x minus 1 is going to be squared because it's tangent to the x-axis right here. Then I've got an x value at 2 and another x value at 4. So x value at 2, that would be minus 2, and an x value at 4, so x minus 4. And I think I made a boo-boo, didn't I? Anybody see that? There should be a plus 1, not a minus 1. And oh my goodness, this is a 4 down here. 4. Okay. Now we need to find the how do you say, y-intercept. So I'm going to use this point right here, which is 0, 2. So 2 goes in for y, and all my x values are c's. So that, are zeros. So that's going to be 4 times 1 squared, which I know is 1. This will be negative 2, and this will be negative 4. All right, so we have 2 equals. Well, let's see. We've got negative 16 times 2, 30. Oh, no, positive, right? Because we have a negative here times a negative here. And that is a 32. Right? So that's positive 32c. Divide out your 32. And that should be 1 over 16, right? 1 over 16 is your c. All right, so last but not least, so we've got f of x equals 1 over 16 times x plus 4 times x plus 1, that quantity squared, times x minus 2 times x minus 4. All right, so if I look at the first one, number 6, I see here that I have 1, 2, 3 x's. So the highest power would be x cubed, which makes that a cubic function. So a cubic either goes 1, 2, 3 directions, changes like that, or 1, 2, 3 direction changes like that. If we look at what we have then, the leading coefficient here is positive, but the leading coefficient here is negative. Well, if you look up here, all my x's are positive, so I'm going to have a picture more like this one. So I'm just going to go like that and cross that out. All right, so I know it's a cubic. I know that it starts going up first. So let's find the zeros. So I have x equals negative 1. Okay, I'm going to put a dot there. I have x equals 2, and then this is just a sketch, 3, 4. Okay, now the other thing that I would need is I would need the y-intercept, right? And the y-intercept would be where the x value is 0. So I'm trying to find f of 0. So I'm going to put in 0 into the original function here, wherever I see an x. So I'm putting a 0 here, here, and here. Okay? All right, so when I put 0 in the first set of parentheses, I get a 1. In the second, I get a negative 2. And in the last one, I get a negative 4. So f of 0 is 8. So that means I'm hitting my y-axis at 0, 8. So I'm just going to pretend like that's up at 8. Okay? All right, so now I'm going to sketch the graph. So it's going to go up, hit my y-intercept, come down, and back up again. And there's my f of x. Okay, and if you look at that picture, it does mimic this little side sketch that we did. All right, let's look at the second one here. Now, I have 3 x's here. I've got a 4th one here and a 5th one here. So this is a 5th degree function with a negative leading coefficient. Okay, odd degree, negative leading coefficient. So it's going to look something like this: 1, 2, 3, 4, 5, like that. Okay, and the reason why I went down first here is because of that negative leading coefficient. I also have a cubic here, so remember what that's going to do to the graph. We'll get there in a minute. Let's go for the zeros. So I have negative 3 and negative 2 and positive 1. Okay, so how about we plot those? So I have negative 3, I have negative 2, and then I have positive 1. Okay, now I would want to find where it hits the y-axis, so I'm going to do f of 0. Remember, that just means put in 0 for your x values. So I've got a negative, and I'm going to open up a set of parentheses. I should have a 3, then a 2, then a negative 1, that quantity cubed. Okay, so f of 0 is going to be equal to, now if I cube a negative 1, that's still negative 1. But this negative 1 times that negative will make positive, won't it? So this whole thing will just be 6. Okay, so this is 6. And so then we know that this graph hits the y-axis at 0, 6. So that's up at 6. Okay. All right, so my graph has to make 5 direction changes, but keep in mind we're going to be doing something funky right here. And I have to start by going down first. So I'm going to start up here like this, come down, that's 1, 2, 3. Now remember, this is where I go from concave, in this case up, to concave down. It does a little loop-de-loop thing like that. Okay, and there's your f of x. All right, last one. So let's count how high of a degree we have. So we have 1x here. We have 2, 3 here, because that's to the second power, so that's 3 total, and another one here, so that's 4. So this is a 4th degree graph, and a negative leading coefficient. Okay, so 4th degree with a negative leading coefficient would look something like that. It's got to open down. Okay, all right, so let's look at our zeros. Well, we have x equals 0, x equals negative 5, but with a squared, we'll deal with that, and x equals negative 3. So let's plot those. So I've got 1, 2, 3, 4, 5, right? So x equals negative 5, negative 3, and x equals 0. All right, well, we don't need to find the y-intercept because this factor right here corresponds to that 0, and that's on the y-axis, so that is the y-intercept. And we need to make it look like this. But remember, at x equals negative 5, we have a tangent. So it's going to ricochet off that x-axis and bounce. So it's going to look something like this, and it's going to ricochet and come back down. Oops, let's pretend that that hit there. Then we're going to come up like this, come through like that, and there's your f of x. All right, so I do notice here that I have a 0 at x equals negative 2, which means then its factor would be x plus 2, which I have right here. So I'm thinking this might be one of the answers. The problem is these guys are not completely factored. So I would probably suggest you do that so we can figure out what the final answer is. So I'm just going to factor those trinomials over here. So what adds to negative 4 and multiplies to 12? So that's going to be x minus 6 and x plus 2, right? Okay, and then this one is going to be x plus 2 and x minus 1. And this guy right here is going to be x, what do we got here? Minus 6 and an x plus 1. Now, what I'm going to do now is these things that I just wrote here, I'm going to add their factors right here to the ends. Okay, so it looks like one kind of cohesive equation. So I'll put the other x plus 2 at the end here. That other one has an x minus 3 at the end here. And then this one has an x minus 1. Okay, so now let's compare. Negative 2, so that means the factor would be x plus 2. Well, this guy doesn't have that, so we can cross off Roman numeral 3. That's no good. However, if you look, these guys both have x plus 2, but this guy has 2 of them. Doesn't that mean you're supposed to have a tangent? Which we don't have here. But we have it here. We're good here. Now this is saying that the factor x minus 1 would have a 0 at x equals 1, which we've got, and x equals 3, which we've got. So the answer is Roman numeral 2, and that would be choice 2. Okay. Okay, so now here, I would suggest that you put in 0, 4, which is the y-intercept. So we're going to have 4 equals C times 2 times negative 2 squared, which is 4, times negative 4 there. Okay, so that's 4 equals, we have negative 32C. Divide out that negative 32. So your C value is going to be negative 1/8. So final answer is f of x equals negative 1/8 times x plus 2 times x minus 2, that quantity squared, times x minus 4. Okay, so for number 10, we're just describing the transformation, and since we have a number underneath the radical that's kind of similar to being in parentheses, so that is always a left or right shift, and it's in the opposite direction of this sign, so since that says minus 7, we're actually going to the right 7 units. Then the number outside parentheses, or in this case outside this radical, is just an up or down shift, and it's always in the direction of the sign, so up 3 units. Okay, so for number 11, we're going to write a new function, so I'll just call it, oops, maybe I should have my pen on, g of x. Now it widens by a factor of 1/3, so I'm going to put that factor right there, 1/3. It translates to the right 3 units, so I know that that's going to be inside parentheses, opposite sign, and that is the original function is a squared function, so I'm going to have that squared, and then translate up 4 units, so plus 4. All right, number 12, very similar, so I'm going to write g of x equals, we have a reflection in the x-axis, so that means we negate a horizontal shift to the left, which is actually going to be the opposite sign in parentheses. Since this is a quadratic, I'm going to have that squared. Then we have a vertical shift up 2, so outside the parentheses plus 2. For the first one of number 13, we see that we have a quadratic, so that's going to be a parabola. We know it's going to open down because we have a negative leading coefficient. We are moving to the right 1 unit and up 3. So let's start by finding that turning point. So we're going to go, let me just get my little pointer here. We are going to go 1 to the right and then up 3. And we're going to put a dot there. Okay, so that's going to be right there. Oops, I'm sorry. Right over here. I'm sorry. It's a small graph for me, so it's hard for me to get a tiny little point. Now, remember we do 1, 4, 9, but in this case, because we shifted to the right and up 3, but because most especially we have that negative leading coefficient, we need to go down 1 to the left and to the right 1. Then we go down 4, 1, 2, 3, 4, and over 2 to the left, and 2 to the right. Okay, I'm sorry, this is really supposed to kind of be right around there. There we go. And then we can go down 9, so this is 4, 5, 6, 7, 8, 9, and then 3. Sorry again, 3, there we go, and 3, there we go. So our picture, as ugly as mine looks, my apologies, there's f of x. Okay, so let's look at the second one. Now the second one is a piecewise function, and again, we have a parabola. It opens up this time because the leading coefficient is positive. We have a shift to the left 2 because the 2 is in parentheses. We go in the opposite direction, and it's squared. Now, let's look at this domain here. We're only going to be graphing the points that are less than 0. So again, I would suggest you start with the turning point, which we know is going to be shifted to the left 2. So there's your turning point. And then we can do the 1, 4, 9 method. So we can go up 1 from that turning point to the left. I might get it. sorry guys, to the left one and to the right one. Well, use your imagination. Okay, so let me just show you. So I went up 1 to the left and to the right one. Sorry about the mistake over here. Then I went up 4 to the left 2 and to the right 2. Now, I have an open circle here because the domain says x is less than 0. So I can't include that value at 0, but anything less than that is fine. So there's what my, those are the points that I would use to make my graph of the parabola. Okay. All right, now I need this line. So I know my y-intercept is at -3, which would be right down here at -3. And then I know that my slope is 1/3. So from here, I'm going to go up 1 over 3, up 1 over 3, and so on. Okay? However, I do want to take into account that my domain is x is greater than 3. So here's x equals 3. So this would be my first point. I actually wouldn't use this point. I used it so that I could figure out what the behavior of the graph was. But my graph is going to start here, but I'm not including 3. So I should have an open circle at that value and then go in that direction. Okay, so that would be my f of x. All right, let's look at the last one. Well, this one I'd like to try to get y by itself. So I am going to move the 3x over to the right side. And while I'm at it, I'm going to move the 2 over also to the right side, which will make those guys disappear. So that's going to give me 2y equals -3x plus 8. Then I'm just going to take everything and divide by 2 so that I can get that y by itself. So that's y equals -3/2 x plus 4. Okay, so then I know that my y-intercept is a +4, which would be right there. And then I know my slope is -3 over 2. So from here, I can go down 3 to the right 2, down 3 to the right 2, and so on. So those would be your points, and then we just connect them. And there's your graph of f of x. Okay, number 14 says slope-intercept form. Please make sure you know the difference between that and point-slope form. Okay, that is slope-intercept form. This is point-slope form. Now, they're talking about a line that is perpendicular to this line. So remember that we know perpendicular lines have negative reciprocal slopes. So my new line is going to have a slope of 7/3. And then x plus b, right? Okay, now we know that it passes through this point, so we have an x and a y value. So I'm going to plug in -3 for y. And I have 7 over 3, and that's going to be multiplied by -5 over 1 plus b. So that's going to be -3 equals -35 over 3 plus b. Okay, so I'm going to add the 35/3 over here and here so that I can solve for b, which is going to cross that out. All right, so what I really have is I want to take this -3 and give it a denominator of 3, which means I'm going to have to multiply both the numerator and the denominator. So let me just use a different color here so you can see this. I'm going to multiply the numerator and the denominator by a 3. Okay, so that we can get that common denominator. So then if we do that, we end up with -9/3 plus 35/3, which is 26/3. And that's your value for b. Okay, now remember that's not the answer, but that helps us get the answer. So we want the equation of the line, so we just have to take this, and we have to take that, and we have y equals 7/3 x plus 26/3. And there's your answer. All right, so you know that I usually like to start by doing the even rule, which is f of x equals f of negative x. So I'm going to start with that. So I already have f of x there, so I'm going to do f of negative x. So that's going to be 2 times negative x, that quantity to the 4th, minus 5 times negative x, that quantity squared, plus 7. Okay, so just remember that this is really negative x times negative x times negative x times negative x. So 4 negatives is going to equal a positive, just like 2 negatives is going to equal a positive. So we've got f of negative x equals 2x to the 4th, because negative x times negative x times negative x, I forgot how many I just said, but 4 of them, is x to the 4th. Okay, minus the 5, and again, negative x times negative x is a positive x squared, plus 7. Now remember, I have you group the original with your final f of negative x and take a good look at that. And you should notice that they're identical to one another. So then you just say, restate the rules, so say f of x equals f of negative x, therefore even. And there's your answer. Okay, I'm going to just throw this one down here. So let's do the same thing again. I'm going to start with f of negative x. I'm throwing it down here just so I have a little bit more room. So I've got 3 minus negative x, because I see an x, I'm putting in a negative x, and I square that, over 2 minus 5 times negative x, and I raise that to the 4th power. So let's work this out. So I get f of negative x equals 3 minus, now once again we have a negative x and we're squaring it, so that's just going to be a positive x squared, and in the denominator 2 minus 5, and then once again let's look at this, a negative x raised to the 4th power. Well, that negative will turn into a positive, and then that x will turn into an x to the 4th. Okay, so let's look at the original. Let's look at f of negative x, and let's look and see if they're the same. And do you see that they are the same? So we restate the rule. So f of x equals f of negative x, therefore even. All right, let's look at this one. So we're going to do the same thing again. F of negative x equals 3 times negative x, that quantity to the 5th power, minus 4 times negative x, that quantity to the 3rd power, minus 7 times negative x. Okay, so now we have something a little bit different than the last two, because I have a negative x but raised to an odd power. So a negative multiplied by itself 5 times leaves you with a negative. So this value, this whole value here, will become a negative 3x to the 5th power. So f of negative x is equal to negative 3x to the 5th. And similarly, if you look here, a negative raised to a 3rd power, that's an odd power, would give you a negative. Okay, so I'll have negative x cubed here, but then that's multiplied by that negative 4. So do you see that this will give me negative x cubed times another negative would make positive. So that's going to end up giving me plus 4x cubed. And then lastly, you've got minus a negative. So that would give us a positive 7x. Okay, so I am going to group this, and I am going to group this. Now, normally I would have you write that sentence off to the right-hand side over here. I just kind of can't fit it, so I'm going to put it underneath here. And if you look at those are not the same. So then you just simply say that f of x is not equal to f of negative x. Therefore, not even. Okay, which means we've got to do the odd rule. So now, the odd rule, just we negate the original function. We negate f of x. So we go back to the original function right here and negate everything here. And that's pretty easy when it's not a fraction. So I'm going to get negative 3x to the fifth. I'm going to get a positive 4x cubed. And I'm going to get a positive 7x. Now remember the odd rule, you group together the f of negative x and the negative f of x. Let's look at those two. Do you see that those are the same? Now again, I can't fit the sentence, so I'm going to write it underneath. So negative f of x does equal f of negative x. So therefore, odd. And that would be your answer for that one. Okay, last one, this fraction over here. So I am going to start by doing f of negative x. So I'm going to put in a negative x in that numerator there and cube that, minus 4. And then in the denominator, 2 times negative x, and that's going to be raised to the 5th power. All right, so let's see what we get here. So we have f of negative x equals, well, negative x when I cube that is still negative. In this case, x cubed minus 4. And then in the denominator, a negative x, if I raise it to the 5th power, it's an odd power, so it's going to keep it negative. Negative 2x to the 5th. Look at this, look at that, and I think you can see that those are not the same. So let me make this look maybe a little bit neater. So I'm going to say f of x does not equal f of negative x, therefore not even. All right, now I kind of can't fit the next part, so I'm going to just scoot it down this way. So I'm going to do negative f of x. So remember, that means to negate the original function. So here's your original function. Please be careful, it's a fraction. So when you negate a fraction, you cannot negate the numerator and the denominator. If you do that, a negative over a negative is a positive, so you really haven't negated anything. So you have to either pick the numerator and negate that, but if you do that, don't touch the denominator. Or you can leave the numerator alone and touch the denominator. It's really up to you. So what I'm going to do is I'm going to show you both. So if I negate the numerator, I would get, oops, got to turn my pen back on. I would get negative x cubed and a plus 4. If I do that, don't touch the denominator. Or if you prefer, you can leave the numerator alone, x cubed minus 4, and touch the denominator, change that one, negative 2x to the 5th. And there's your negative f of x. So it's either this one or this one. Now the goal is to look at one of these and see if it matches this guy right here, right? Because we want to see negative f of x, and we want to see if it's equal to f of negative x, because that would determine whether something's odd. Well, if you look up here, I have a negative x cubed. That's a negative x cubed. But here I have a negative 4, and that's a positive 4. So that doesn't work. And right here, I have a negative 4 like this, but this is a positive x cubed, and that's not. So hopefully you see that we don't have an odd function either. So I'm going to group these two right here, okay, and I'm going to write the sentence underneath. So negative f of x does not equal f of negative x, therefore not odd. Now please, on your test, don't just stop right there. So if it's not even and it's not odd, don't forget that you have to write the word neither. If you don't write the word neither, you're going to lose a point, and that just really stinks. I don't want you losing points over something silly like that. Okay?